So this is the key that I made for the quiz that you took a few nights ago. And when we went over it, or when we talked about it in class on Wednesday, people thought it would be helpful for me to kind of walk you through it. In number 1, when we want to know what is the position at 4 seconds, this integral will give us the change in position over that time interval, otherwise known as the displacement. What we need to do is know also where it started at 0. Okay, so once I found out what this was, found this value of integral using f and int, then I just added it to the original position. Now, when you use f and int, you want to use y1, and so I plug the equation into y1 here. But then remember that f and int needs four arguments in it. So when you use f and int, you're going to do math 9. I want y1. Okay, I want y1. My variable is x, and then I'm integrating from 0 to 4. Okay, and it takes a little while to integrate this, but then after I get this value, then I'm just going to add the 13.215 to it. I'm just going to let that go, let that calculate. Now, find the total distance traveled over the first 10 seconds. Then we are going to use absolute value, because total distance means taking into account the distance in one direction and then the distance in the other direction. And here you can see the value of that integral, and now I'm just going to add 13.21 to it. Now in number 3, I used the numerical derivative. Okay, so I used the derivative of velocity, and then I just found the values of velocity and acceleration at 4 seconds. Now notice they both have the same sign, therefore it's speeding up. And if they ask this question on Tuesday, be sure to state that they have the same sign. It's not that they're both negatives. If they were both positives, you wouldn't say it's because they're both positives. The idea here is that they have the same sign. If they have opposite signs, then it's going to be slowing down. Now, in number 4, when is the particle at rest? I want to know when is the velocity equal to 0. So I used Math Solver. Now, in number 8, I asked you to include a rough sketch. So here's my sketch, and so I'm looking for these 2 points when the velocity is 0. It turns out to be about 2.417 and 7.250. Now, in order to use Math Solver, remember that that's going to be at math 0. And the first screen asks you for the function that you're talking about. And then when you toggle down, then you need to put it you need a guess. And by looking at that graph, I would maybe guess 2 or 3, and then over here maybe 7 or 8. But that's why you want to take a peek at your graph first of all. Okay, and then when you're going to use Math Solver, it's asking you for a value here. So I'm going to just say 2.5, and then you do alpha, enter, and then it will give you your value. Remember, we're going to go to 3 places here, so that's why I had the answer I did. Now, when is the acceleration 0? And that would be when the derivative is 0. So I'm going to use one of these, either y2 or y3. And actually, if you want to plug it in here, that might be useful later when you're graphing. But otherwise, you can just use Math Solver and have it the derivative of y1. But sometimes I think it's easier to go like this. Math 8, the derivative of y1, comma x, So now we have input the derivative of y1 into y2. And then when we use Math Solver, we can just find out when y2 is equal to 0. Okay. Number 6, when does it first reach a speed of 33? Remember that the speed is the absolute value of velocity. So if you look at the graph here, you can see that it will reach negative 33 before it reaches positive 33. So we want to find out when this your velocity function intersects with y equals negative 33. Number 7, I'm asking, is there a time in the first 10 seconds when the position would be the same? And if you think about it this way, here's your velocity function. You're moving to the right, so this would be the distance that you are moving to the right, and then this is the distance to the left. And when these two areas are equal to each other, then we will be back at the starting position back here at 13.215. So if you wanted to actually come up with that value, you could just integrate from 0 to some value, and you could just guess here. You guess here until that the value of that integral is equal to 0.